Moving on now to disaccharides. Lactose is a disaccharide that's found in milk and milk products. It contains the monosaccharides, galactose, and glucose. So we get to learn how to describe the monosaccharide units and how they link to form disaccharides. So a disaccharide, remember, look at those words. Di means two, saccharide is your sugar. So this consists of two mono or singular saccharides linked together, and it's formed when two monosaccharides combine in a dehydration reaction. So remember we talked before about hydrolysis reactions? Hydrolysis reactions are using hydro or water to lyse or break apart something, where a dehydration reaction, that's what sticks things together. So I always think of making beef jerky, okay, or dehydrating fruit, something like that. What do? You're going to put it through this reaction to take out water, and then it makes those cells stick closer together to actually make this wonderful beef jerky or fruit leathers or whatever you're making, okay? So my chair's squeaky. So again, the dehydration reaction is an important keyword there. So when we have these monosaccharides, if we have glucose and we add another glucose, it forms the saccharide maltose. And remember, since we're having a dehydration reaction, we're taking out a hydrogen from one and an OH group from the other. So that's how we are going to form our water. When we link together glucose and galactose, that gives us lactose. When we link together glucose and fructose, that gives us our sucrose. And so the most common disaccharides, are maltose, lactose, and sucrose. So what is maltose? Well, this is a disaccharide that is also known as malt sugar. It's composed of two D-glucose molecules, and it's obtained from the hydrolysis or breaking apart of starch. This is used in cereals, candies, and brewing, and they're found in both the alpha and the beta forms. So how do we form this? Well, remember, we're going to be doing a dehydration reaction. We're taking off the OH group from one glucose and the H group from another glucose, linking it together, forming a water right here and making a disaccharide. So maltose is linked by an alpha 1,4 glycosidic bond that is formed from the alpha OH on carbon 1 of the first glucose and the OH on carbon 4 of the second glucose. Okay, that was a mouthful. So, but it should start making sense right now because we talked about basically the geography of these rings. Okay. So what is lactose? Well, people can be lactose intolerant, so it would make sense that this would be a milk sugar, okay? So lactose is a disaccharide, and that's found in milk and milk products. And this makes up 6 to 8% of human milk and about 4 to 5% of cow milk. And so again, we're going to be taking the OH group from a galactose and linking it to a glucose to make a lactose, okay? So again, that dehydration reaction when we're forming a water. So lactose is a disaccharide of beta D-galactose and alpha or beta D-glucose. So again, this is how we're linking them together, different formation, okay? So the bond in lactose, beta 1,4 glycosidic bond, because the OH group of the carbon on the 1 of beta D-galactose forms a glycosidic bond with the OH group on carbon 4 of the D-glucose molecule. Whoa, that was a mouthful. But again, break it down and just think of the geography that we're talking about, and that will make sense. Okay. Now, what about sucrose? Well, this is really common, right? This is table sugar. So it's obtained from sugar cane and sugar beets. Now, I live in Michigan, and we raise, not my family, but Michigan raises a lot of sugar beets. So like Pioneer Sugar is based, I think, in Battle Creek, Michigan, right? So there's a ton of sugar, and so I'm partial to sugar beets. But down south, you're going to have more sugarcane sugar. But anyway, this consists of an alpha D-glucose and a beta D-fructose that are linked together. So it has an alpha beta 1,2 glycosidic bond between the carbon 1 of glucose and the carbon 2 of fructose, okay? And it cannot form an open chain, and it cannot be oxidized. So therefore, since it can't be oxidized, it can't react with that Benedict's reagent, and it is not a reducing sugar. So this is your lovely picture showing how we are going to be linking those two together, okay? So the sweetness of sweeteners. Sugars and artificial sweeteners, they differ in sweetness, and they're compared to sucrose or our regular table sugar. And this is assigned a value of 100. So if we look at the monosaccharides and the sweetness, galactose and glucose are going to be less sweet than sugar, where fructose is going to be more sweet. And fructose is in a lot of fruits, right? So your disaccharides, again, not so bad. Then sucrose is your litmus. And then your sugar alcohol, blah, blah, blah. And then look at these artificial sweeteners. Look at how insanely more sugary they taste, right? So this is why if you ever have put like Splenda or something like that on your tongue, it's like almost bitter because it's so sweet. It's like ridiculous. And that's because exactly of this. That's the sweetness, okay? So talking about these artificial sugars, when we talk about sucralose, Sucralose is marketed as Splenda, and it's made from sucrose by replacing some of the hydroxyl groups with chlorine atoms, okay? So you can see here, this is the chemical structure of sucralose or Splenda, okay? And you can see we have chlorine, right? So this is what's going to make that Splenda. What about aspartame? We hear a lot about aspartame and, don't eat anything that has aspartame in it because it's bad. Well, okay. Aspartame is marketed as NutraSweet or equal, and they actually do taste different. So your homework for this week, if you remember, you're not going to be graded on it, but I think it would be fun to go to, I don't know, well, we're in the middle of COVID right now while I'm taping these. I was going to say go to a restaurant, take a packet of each, and taste them and see the difference. Okay. Anyway, aspartame is marketed as NutraSweet or equal, and this is a non-carbohydrate sweetener that's made from aspartic acid and a methyl ester of the amino acid phenylalanine. Okay, so this is from aspartic acid, this is from phenylalanine. We have a methyl ester here at the end, and this is what the chemical structure of aspartame or NutraSweet is. So let's do your favorite thing, study checks. So let's identify the monosaccharides in each of the following. Okay, lactose, maltose, sucrose, and the different subsets. Okay, so pause me and come back. So what did you get? Okay, so for A, it's going to be lactose is made up of an alpha D-glucose and a beta D-glucose. Maltose has an alpha D-glucose. Sucrose has an alpha D-glucose and a beta D-glucose. Okay, so great job, you guys.